Hello everyone, you're welcome to solve this nice exponential equation, which is 8 to the power x plus 2 to the power x. This is equal to 130. What is the value of x? Now let's prevent the solution here. We can express 8 to the power x as 2 to the power 3 raised to the power x, then plus 2 to the power x. This is equal to 130. Now 2 to the power 3 raised to the power x, this is in the form of 8 to the power n raised to the power m, which we can express as a to the power m raised to the power n. Applying this exponent property, then we have 2 to the power x raised to the power 3, then plus 2 to the power x. This is equal to 130. The next step from here, let's take 130 on the left hand side so that we have 2 to the power x raised to the power 3, then plus 2 to the power x, subtract 130. This is equal to 0. Now, from here, we have 2 to the power x here and 2 to the power x. So we can just say, let 2 to the power x be equal to m. So that now from here, we can substitute where we have 2 to the power x with m. So we have here m to the power 3, then plus m, subtract 130. This is equal to 0. We can express 130 as 26 multiplied by 5. So this implies that from what we have here, we can express m as 26m subtract 25m. So if you see 26m minus 25m, this is the same thing as m. So let's substitute here. We have m to the power 3 plus 26m subtract 25m subtract 130. This is equal to 0. From here, we have 26 here. We can express 130. We can express 130 as 26 times 5. So subtract 26 times 5. So this is equal to 0. We have 26 here and we have 26 here. So we can express this as m to the power 3 subtract 25m here, then plus 26m, then subtract 26 times 5. This is equal to 0. So from what we have here, we have 26m, we have 26 and 26. So this will help us to factor out 26. But here we have that m. We can factor out m here so that we have m into the parentheses m squared minus 25. Then plus 26 is common, so we have 26 into the parentheses m minus 5. This is equal to 0. So m squared minus 25, this is actually the difference of two squares expressed as a squared minus b squared. So we can express this as a plus b, a minus b. So this implies that we have m into the parentheses. Here we have m plus 5, then m minus 5, then plus 26 into the parentheses m minus 5, close the bracket. This is equal to 0. So m minus 5 is common here. We can factor out m minus 5 so that into the parentheses we'll have m multiplied by m plus 5, then plus 26, close the bracket here. This is equal to 0. So here we have two parts. The first part is m minus 5, this is equal to 0. The second part here, we have m times m plus 5, then plus 26. This is equal to 0. So from the first part here, we have m1 is equal to 5. For the second part here, we can form a quadratic equation, which is m squared plus 5 times m, which is 5m, then plus 26. This is equal to 0. Now, this is a quadratic equation of the form am squared plus bm plus c. This is equal to 0. From this quadratic equation, a is equal to 1, b is equal to 5, and c is equal to 26. Now, let's check the nature of this quadratic equation. Let's check the nature of the root of this quadratic equation by determining the discriminant value, which is b squared minus 4 times a times c. So let's substitute the values of a, b, and c. So here we have 5 squared minus 4 times a, which is 1, then times c, which is 26. So here, 5 squared is 25. Subtract, we have 26. 26 times 4, this is 104. So if you say 25, subtract 104, this is negative 79, which is less than 0. So this is to clearly mean that this part will not give us a real solution. So there is no real solution for this quadratic equation. So in other words, we have two complex solutions. Two complex solutions. So since this part will not give us a real solution here, so this implies that this quadratic equation part is rejected. So let's reject this part. And let's focus on m1, which is 5. Now, given that we have m1, which is 5, and if you recall, we insist that let 2 to the power x be equal to m. So substituting the value of m, we have 2 to the power x. This is equal to m, which is equal to 5. To solve for x, we introduce logarithm on both sides. So we have log 2 to the power x. This is equal to log 5. So log 2 to the power x, this is in the form of log a to the power n, which we can express as n log a. Applying this power rule property of logarithm, then log 2 to the power x, we can express this as x log 2. This is equal to log 5. Let's divide both sides by log 2 here. So that now x will be equal to, again here, log 5 over log 2. This is in the form of log a over log b, which we can express as log a to base b. Applying this logarithm property, then we can express x as log 5 to base 2. So this is the value of x. This is the value of x. So let's verify that this value of x satisfies the equation. Now let's verify that this value of x, which is log 5 to base 2, satisfies the equation. Now if you recall here, we end at 8 to the power x plus 2 to the power x. This is equal to 130. Let's check if this is true. Let's substitute the value of x here. So we have 8 to the power log 5 to base 2 plus 2 to the power log 5 to base 2. This should give us a value of 130. Now, we can express 8 as 2 to the power 3. So we have 2 to the power 3 raised to the power log 5 to base 2, then plus 2 to the power log 5 to base 2. This is supposed to give us a value of 130. The next step is that 2 to the power 3 raised to log 5 to base 2. This is in the form of 8 to the power n raised to the power m, which we can express as 8 to the power n times m. Applying this exponent property, then we have 2 to the power 3 log 5 to base 2, then plus 2 to the power log 5 to base 2. This should give us a value of 130. So 2 to the power 3, this 3 is a power, so we can express this as 2 to the power log 5 to the power 3, then to base 2, then plus 2 log 5 to base 2. This should give us a value of 130. Now, 2 to the power log 5 cubed to base 2 plus 2 log 5 to base 2. This is in the form of m to the power log a to base m, which essentially we can express as a. So let's apply this logarithm property so that now 2 to the power log 5 to the power 3 to base 2, this is the same thing as 5 to the power 3, which we can express as 5 to the power 3, this is 125. And then we have 2 to the power log 5 to base 2, this is equal to 5. So, substituting this, we'll have 125 plus 5. This should give us a value of 130. So 125 plus 5, this clearly is 130, which is equal to 130. So this clearly indicates that the left hand side is equal to the right hand side. And this defines that x, which is log 5 to base 2, actually satisfies the equation. So kindly follow the steps, like this video and subscribe. Like this video and subscribe.